In a flexible container, 16 liters of gas is under 590 kilopascal of pressure at a temperature of 57 degrees Celsius. If the pressure and temperature change to STP, what is the new volume? So let's look at each of the given. We have here 16 liters of gas. So this is your initial volume or V1. Under 590 kilopascal of pressure. So this is your initial pressure or P1. At a temperature of 57 degrees Celsius. So this is your initial temperature or T1. If the pressure and temperature change to STP, what is the new volume? So remember, what does STP mean? STP means standard temperature and pressure. And STP has fixed values. Standard temperature is 273.15 Kelvin. So this is your new temperature or P2. The standard pressure is 101.325 kilopascal. So this is your P2. And the problem says, what is the new volume? So it's asking for V2. So based on the given, it's obvious that we will be using the combined gas law. So what's the formula for combined gas law? It's P1 V1 over T1 equal to P2 V2 over T2. So P1 is 590 kilopascal. V1 is 16 liters. T1 is 57 degrees Celsius. But please take note, if you can remember, if you are using ideal gas equations, like the combined gas law, the temperature must always be in Kelvin. And what is given to us is 57 degrees Celsius. So we need to convert first 57 degrees Celsius into Kelvin. So how do we do that? Remember, if you want to convert Celsius to Kelvin, you add 273.15. So 57 plus 273.15, that's equal to 330.15 Kelvin. So that is your P1. P2 is 101.325 kilopascal. V2 is unknown. We're looking for V2, so just write V2. And then T2 is 273.15 Kelvin. So let's just do a little bit of math to solve for V2. So what you want to do first is you cross multiply. So that becomes 590 kilopascal times 16.0 liters times 273.15 Kelvin equal to, on the right side, we have 101.325 kilopascal times V2 times 330.15 Kelvin. Then, if you want to solve for V2, what you want to do is you just divide both sides of the equation by 101.325 kilopascal times 330.15 Kelvin. So you do that on both sides of the equation. So as you can see, 101.325 cancels on the right side. 330.15 also cancels on the right side. So what is left is V2. And on the left side, you can see kilopascal would cancel, Kelvin would cancel. So what remains is liters, which is the unit of volume. Now you just have to solve this using your calculator. 590 times 16 times 273.15 divided by 101,325 times 330.15. So the answer to this question is approximately 77.1 liters. And that is the answer to this problem.